In this video, I want to talk about section 1.5, which are polynomials and factoring. We're going to go over the different terminology we use to talk about polynomials, working with polynomials, add, subtract, multiply, divide, and some common factoring methods, which you're going to want to know really well. Hopefully you already know a few of them. So polynomials with a single variable. A polynomial in the variable x of degree n can be written in the form where all those with those subscripts are the different coefficients, and x is going to be raised to the highest power n, and then a bunch of lower powers of n, basically. We like to write it in descending order of the powers. So the first term that we're going to write is going to be the term that contains the variable with the highest power, and we're going to go in descending order of these powers. Okay, the coefficient of the term or that has the highest power of x is called the leading coefficient of our polynomial. So a polynomial is an expression where the powers of x are always positive integers. Okay, that's what makes it a polynomial. And the degree of our polynomial is going to be the highest power of x. So in this example, 2x to the third minus x plus 11. Notice it's right at each term is ascending order of degree. This is a degree 3 polynomial. Okay, it also has 3 terms. So that's something to notice, as well as there are 3 specific different terms. 5x, for example, would be a single term of the 5x plus 2. Now the 5 itself is just the coefficient of that term. So you want to make sure you understand each little chunk that's being added and subtracted is a term. And then the terms themselves have their numerical part, which is the coefficient, and they have their variable part. Okay. Here's another example. If you have one term, we call it a monomial. If we have 2 terms, we call it a binomial. And if we have 3 terms, we call it a trinomial. Anything more than that, we just call a polynomial. These then also are polynomials. So how do we add and subtract our polynomials? We just use the properties of real numbers to simplify these guys. So in our first example, if we have x squared minus 6x minus 6 plus 3x squared plus x minus 1, we can just remember that this addition is commutative and associative. So we can just regroup our terms and add our like terms together. So you notice we can add our squared terms. We have 1 of these x squared plus 3 of these x squared, so we have 4x squareds. We have negative 6 of the x's plus 1 of the x's, so we have negative 5 of the x's. And we have negative 6 minus 1, so we have negative 7. Okay, so that's addition and subtraction. We just use our like terms. Be a little more careful with subtraction, because notice the parentheses mean that we are subtracting every one of those terms. So here we have an 8x squared, and we're going to subtract the 4x squared to get a 4x squared. And then we're also subtracting a negative 3x, which is going to make it a positive 3x. And then we've got 6 minus 2, which is going to be a 4. So be very careful. Notice why we have that positive 3x there, okay? And be careful when subtracting polynomials. Let's talk about multiplying polynomials. Here, you just have to distribute all the terms and then simplify. All right, so in our first example, we're going to distribute that negative 3x squared to each of the terms in the parentheses. And then we're going to use the fact that multiplication is commutative and associative and simplify each of those 2 terms. In our second example, we've got 2 terms in the first polynomial and 3 terms in the second polynomial. So when we do all the combinations there, we end up with 6 different terms that we can simplify into these 4. Right? If you need to look over these again, go ahead and pause the video here and work out how I got to these answers. Now let's talk about factoring. All right, factoring is very important. You have to do it a lot and you want to get good at it. We're going to talk first about the greatest common factor method, which is probably something you've seen before. And this is where we just look at each of the terms and find the factors that are common to every single term and factor that factor to the outside of some parentheses. This is basically the opposite of the distributive process. So we're going to factor, I'm going to work through these 3 examples for you. Let's take a look at that first example, 12x to the 5th minus 4x squared plus 8x to the 3rd times z to the 3rd. Okay. If we want to factor this, we have to look at each term. So what is common between all the terms? All of them are even coefficients. So we know we've got at least a factor of 2. And really, I think all those coefficients are divisible by 4. So we know that 4 is a factor that is common to each of the terms. They also each have at least 2 powers of x. So 4x squared is the greatest common factor, common to all 3 of our terms, meaning that all 3 of our terms can be divided by 4x squared. So we break each of our terms up into the 4x squared part and the remaining part. And then we undistribute that 4x squared part and see what we are left with. Okay, be very careful to notice that this term is 4x squared. So we need this remaining -1 to hold the place for that 4x squared. If I were to then multiply through and distribute this 4x squared, you want to make sure you're going to get back to your original thing. Factoring is not changing your polynomial, it's just reorganizing everything that's already there. Let's do our second example. -24ax squared plus 60a. You can see that our common factor is going to be that -12a. Now you can decide, do you want it to be a -12a that you pull out or a +12a that you pull out? It is up to you. But notice how if we pull out the -12a, then this +60a becomes -12a times -5. So we break this positive into 2 negatives essentially. And we follow the same process to undistribute that -12a. If we had just pulled out a 12a, then we'd have 12a times -2x squared plus 5. Our third example is already kind of partially factored for us. We've got a squared minus b minus 3 times a squared minus b. So you can see that that a squared minus b is our common factor. And notice that our first term has 1 of these a squared minus b's. So we push that 1 into there just so we can really see that placeholder before we pull out the a squared minus b. Okay. That's factoring the GCF. That's really the first thing you're always going to do. And then here's another technique called factoring by grouping. This is something we're going to work on more when we factor polynomials that are not quadratics or binomials. We use factoring by grouping in higher degree polynomials or polynomials with a lot of terms. So to factor by grouping, we basically group the terms that share common factors and just factor the GCF out of these groups. Okay. So for example, in our first problem here, this 6x squared minus y x minus 3xy, you notice that all 4 terms don't share any common factors. So if we tried to factor out the GCF, we couldn't. But if we pair these terms up, the first and the third term and the second and the fourth term do share factors. So we can put them into groups and factor there and then see if maybe we get lucky and that those new groups share common factors. So for our first problem, we notice the first and the third term and the second and the fourth. So we can factor a 2x out of the first term, and we can factor a y out of the second and the fourth. And then we get a little bit lucky, which isn't really luck. That's just how this problem factors. Really wouldn't factor. We see that we actually have a 1 plus 3x in both of our new groups. So really, we started out with 4 terms. Once we factor by grouping, we have 2 terms added together. This first term has a single factor of 3x plus 1. This second term has a single factor of -1 minus 3. But if we pull that -1 out, it also becomes a 3x plus 1. So we pull that -1 out. We get a 3x plus 1 and a 3x plus 1. And we can now finally factor off the 3x plus 1, and we are left with the 2x minus 1.